Yes, I'm a venture capitalist. I'm a partner at Amadeaus Capital, and this is the slide showing you the credentials on AI. These are a few of our AI investments. According to PitchBook, we're actually Europe's most active AI investor, and we've been doing this not only since last summer when The Guardian and everyone else picked up on the fact that this might be a thing, but for quite a few years. You'll see on there, and this is from an investor perspective, a challenging bit. You'll see fundamental foundational technologies. GraphCore is building a chip that is optimized for artificial intelligence. Prowler is building this massive decision-making platform, and then you have others that are a lot more focused and address certain verticals. Now, this is what you roughly get when you start looking at AI. There's a ton of stuff in there, and this is all scientifically and from a research perspective really super exciting. But how on earth do you build a business from this? Because that is actually my job. I need to find these things. And because I am not a data scientist or a physicist or a mathematician, I need to start a lot easier. And so I went back to the heart of the matter, and that is data. Simpleton I am, I asked first, okay, how much of this do we actually have? And I go into the internet, as one does these days, and it will tell you that in the year 2018, we've transacted IP traffic to the tune of 1,800 exabyte. Impressed? I asked myself, what the fuck is an exabyte? You're all very clever. Who knows? It's a very, very large number. It's 10 to the power of 18. And then we still go, yeah, whatever. What is that? Therefore, you have this nice picture behind there, which is the Library of Congress. It's the largest library in the world, unless you ask the folks of the British Library. They think they have about 5 volumes more. But on 1 exabyte, you could store the entirety of the Library of Congress 100,000 times. So last year, we've transacted information over the internet to the tune of 180 million times the largest library in the world. And by 2025, this is predicted to go to 180 zettabyte, which is even more. Now, because we still don't know what that might mean, I brought you a dinosaur, and a dinosaur with a MacBook. So if that dude would have pressed download on a file of that size just before it got extinct, that download would complete roughly round about today on present day broadband speeds. Oh, there it is. I come from the other side of the Pennines and live very close to Jodl Bank. And if you're a science geek, then you will know what it is. And if you would be a music fan, you would actually be there right now because there's a very cool music festival. But it's home to what I think is one of the coolest science projects of our time at the moment, which is the Square Kilometre Array. And what they're doing is they're building 2 massive arrays, well, of a square kilometre each, one in South Africa, one in the northwest of Australia. When they switch this on, the data output of this planet will go up by, at the moment, a factor of 3. And then when you ask those people, like, how'd you handle this? You know, you can't go say, Paul, can you get me the data from yesterday on a USB stick? Now, as a consequence, at the University of Manchester, of which Jodl Bank is part, they now have, there's research groups looking at real-time data compression, real-time data analytics, transfer rates, all that sort of stuff. Now, what we also have, though, at the moment is new data sources, which we didn't have in the past. And you find them in the weirdest places. For instance, in Arkansas. Arkansas is home to a steel plant, which is called what were they called? Big River Steel. And this is a screenshot of their website. So they basically say, well, we just happen to be making steel, but we're a technology company, and this is how the CEO explains this, because they approach the production of steel in pretty much the same way as Elon Musk's team on autonomous cars would approach that, because they basically said, right, at the end of the day, it's a data problem. And in the cities we live in, you can basically use them as a smart data canvas. When you think about this, and I'm a layman in this respect, and just sort of like thinking aloud, I could come up with all these things that are being gathered and that are being collected and that are being sorted into some sort of data warehouse. What that means is, we've known Moore's law on computing. What we're seeing, however, at the moment is that we're seeing massive advances in data capture because we're seeing a massive proliferation of the number of data sources, namely sensors that are deployed in the wild. And this is why you spoke to this. 5G is such an important thing, because if you have a sensor that just sits there and senses stuff but can't communicate it to something else, then it is not very useful. Now, all this stuff flows into big data lakes. And previously they were called data warehouses, and the way a data warehouse used to work was you had a huge warehouse, and then you have the big warehouse doors, and you open them, and you throw your data in, and you close the doors, and you walk away. And data lakes, data warehouses, most of that data is dirty. It's unstructured and therefore completely useless. So again, from an investment perspective, this is kind of like the landscape I'm looking at, and then there's a ton of startups coming to us and says, hey, I have a great idea. How did that come in there? So what we're looking at the moment is a world that is no longer just connected, but it is interconnected with each other. And what these things are doing is that the dirty data that you have usually comes pre-tagged with something. If my car coming over from Cheshire over to Leeds detects that there's a bump in the road, then it will communicate it back, and the next time it will hopefully be able to travel around it, or what would be even better, it would ping Highway England and say there's a pothole in the road which we need to fix. And when you then if you have these pre-tagged data points, you can start building stuff like this. This is a drone-generated 3D point map, which is pretty special because it's engineering-grade accurate. But other than that, it is just a fancy-looking, grainy photograph type thing. Now, what the guys who are building this have been doing, and unfortunately is not one of our investments, we weren't quick enough on that, they basically just pull across a layer that allows engineers who need to construct a bridge over that new motorway, and they can do this basically without standing. You remember those people with their camera stand type things, and they're measuring forever and a day, and it takes them usually for something like this 2-3 weeks, and then they go back and say, oh shit, I forgot that one, and then they need to come back the next week. They can do this now on their desk, and more interestingly, they can then collaborate, and then they can call the big lorry company that shifts all the soil away, and they know exactly what the earth displacement of that motorway junction will be. All based on data that is smart and structured data because it's been tagged and allocated. What you can do with those 3D point maps, though, is you can attach any piece of data to any point on that map if you want. So going forward, you could, for instance, use this. You know, if there's a sensor that measures air quality, you would use that, and it's on there. And then the same canvas, so to speak, would then going forward be used by authorities that measure air quality around the country, whatever that might be. What we are seeing in this world is more dimensions. And it is because we have more sensors that produce more raw data, and then we can use machine learning and AI and all those wonderful acronyms that I had put up there, which you can learn all about this all today, to turn this into more structured data. And with more structured data, if we apply this the right way, we can create more sense. And anyone who can do this is interesting to us as investors. And my way of saying don't focus on general artificial intelligence is to compare Prince with Miles Davis. Prince, I think, was proficient in something like 22 different instruments. That is pretty exceptional. Unless you can play 22 different instruments, try at least play one really, really well. In other words, don't try and build an AI that can solve every single problem under this planet, but do one thing and do it well. With that, I think I stop. Maybe? Yes. Thank you.